In this video, we're going to find out how to calculate the missing angles in each of these right triangles. We're going to use this using the trig functions and the trig equations we've been talking about for finding ratios and finding sides, sine, cosine, and tangent. First step, as with all of the different types of problems, the three different types, the first step is to label the side lengths. If your angle is right here, this becomes your opposite side length. This side is this side over here, the side length with 8 on it is hypotenuse, and then 6 is going to be your adjacent. All right. So finding the missing angle here, you have to use cosine because there's no information about the opposite side length. And if we go to SOHCAHTOA up here, if I have no opposite side length, I can't use sine S. I can't use tangent because both of those have an opposite side length. Cosine is the only one that doesn't. So I can use cosine here. So cosine of, it's a question mark. We're going to use the Greek letter theta. It's commonly used for angles. Cosine of the angle theta is equal to, and this is adjacent over hypotenuse, A over H. So it's going to be 6 over 8. So we need to get the theta outside of the trig function. And you can't just do divide by cosine both sides because this is not multiplication. This is all one thing. All right. So what you have to do is do the inverse of cosine to both sides. And what the inverse of cosine does is it undoes the original cosine. So watch as I write this down. Cosine and the inverse cosine is just, a cosine with a little -1. I'm going to write this on both sides. And inside my inverse cosines, I'm going to write what was above here. So I'm going to bring this down. Cosine of theta. And then 6 over 8. So I've just taken this equation. I've done inverse cosine to both sides. And the whole point of that is cosine, or inverse cosine of theta is kind of like square rooting a square. You end up with the original number. So in this case, they cancel out the theta. This right here, inverse cosine of 6 over 8, you can type that into your calculator. You're going to get some kind of decimal. So, in case you're wondering how to type it in, zoom out here. If you press the second button, and then press cosine, it brings up inverse cosine. Type in 6 divided by 8, 6 over 8, and you get 41.41, we'll call it, degrees as an angle. Get 41.41 degrees as your angle. Just to recap on this problem, label the side lengths, choose the trig function, solve using inverse cosine, and then round your answer. Let's look at number 6. Number 6 is slightly different than number 5. If you'll notice, number 6, you have all 3 side lengths labeled with an actual measurement. Here we only had 2. So the implication is, if I have all 3 available to me, that means I can use any one of these up here. There's no restrictions on the trig function. So I know this is opposite, 16, I know 34 is going to be hypotenuse. I know 30 is going to be adjacent. And I am able to choose sine, cosine, or tangent. It does not matter which one you choose. If you had 3 people do one of each, they'd all get the same angle here. So I'm just going to choose tangent. And tangent is going to be opposite over adjacent. So tangent of theta is going to be equal to 16 over 30. And it's important to show your work here. You want to make sure everything's nice and neat. Tangent or inverse tangent on both sides. And what happens here? Inverse tangent of tangent is equal to just theta. If you want a visualization of this, you take your calculator and you do second tangent, tangent, so inverse tangent of let's say 5. I'm making up a number. You press enter here, the calculator is going to evaluate tangent of 5, then it's going to do the exact reverse of what I just did. So this is going to undo the original function. What happens here is left with 5. Same thing here. If I have inverse tangent of theta, that's going to be equal to just theta. Inverse tangent of 16 over 30 is something you can calculate very quickly. Second tangent, and then 16 over 30, 28.07 degrees. And that's how you find the angle. And again, I chose tangent, but someone else could choose sine or someone else could choose cosine. As long as they use the correct ratio, not the same one I have, but their own correct ratio, you're going to get the same exact theta. So, recap, label, 3 side lengths, choose the trig function, whether you have to choose one or you can choose whatever you want. Make a choice, write the equation. This is the same first equation step as the other 2 types of problems. And then you're going to solve using inverse trig to find your theta angle. Make sure you put degrees because you are finding the measure of an angle. And that's it.